So good afternoon, everybody. It's a pleasure to have with us Professor Juliana Puello, who has more than 15 years of teaching and research experience in academia, working on projects related to physical, chemical, rheological, and thermal behavior of heavy crude oils and heavy fractions. Her first experience in academia was at the Universidad Industrial de Santander, where she received both her PhD and her master's degree in chemical engineering. She is currently a full professor at the chemical engineering department at the Universidad San Buenaventura in Cartagena, Colombia, and as a director of the master program in the process engineer. And thanks to the close relationship between the university and the refining and petrochemical companies in Cartagena, she has participated in programs and projects related to energy area in general. This experience has brought her interest in process safety, where heavy oil fractions are involved. Several conferences and papers and international events and journals have been developed in this topic. More recently, back in 2019, she put together a collaboration project with our university and our department, where Juliana is working on explosion modeling, numerical explosion modeling of lithium-ion batteries. So without any further ado, I would like to thank you again, Professor Juliana, for accepting our invitation and for being with us today. And I hand the word to you, Juliana. Thank you.
Okay, thank you very much, Professor Savio, for this kind invitation to share with the community, the academic community, and also industrial community about the hazards in delayed cooking units with this presentation. As Professor Savio told you, well, I am a professor at the School of Chemical Engineering at Universidad de San Buenaventura, Cartagena. Today, I want to share with you, I want to be sure, Professor Savio and Maria Fernanda, to tell me if my screen is online, if you can view my screen about the outline of this presentation. Okay, I guess that we are here at the outline where I will present the motivation that brought me to review on this topic and also the description of the delayed cooking processes. Then I will mention some chemical and process hazards in a very short way. Also, I will present some incidents in delayed cooking units and some mitigation suggestion for these hazards in delayed cooking units. Well, the motivation that brought me to this topic is because my background in research has been related to the characterization and understanding of the behavior of heavy oil fractions, heavy crude oils, and also with the need for a stronger safety culture in the industry. Also, that we can include elements of process safety in our chemical engineering courses, and the location of our refinery and petrochemical industry here in Cartagena that has gone over an expansion project that increased the capacity for this refinery to process from 80 kilobarrels per day to 165 and now to 200 kilobarrels per day. Now the delayed cooking unit here has a capacity of 40 kilobarrels per day. So that combined is what has motivated me to be in a close relation with the people, the students, the workers that are at the refinery and that also attend our courses here at the university. They have been very helpful and motivating for this topic, considering the background in heavy crude oils, heavy oil fractions, and the interest in process safety. Now, uh, I want to describe what is delayed cracking first. This is a thermal cracking process used in petroleum refineries to upgrade and convert petroleum residue, what is the vacuum tower bottom. And this vacuum tower bottom stream is converted into liquid and gas products that leave behind a solid concentrated carbon material, which is called petroleum coke. As you can see in this slide, this process yields lighter fractions that can be processed to obtain higher value products. Here in these pictures, you can observe that these delayed coking units, they are usually configured with two drums that I will I will point out here. These are the drums where the cooking takes place. And also, this is the cutting system. This is a very complex system of cranes and lines that allow to cut and to break the coke after it has solidified here in the drums. Okay, these units are characterized because they have always two drums in each module. Here, I am presenting this picture of the delayed cooking unit in Cartagena. We have two modules, so in total we have four drums. There are refineries that have more than four drums. They can even be like cooking units that have eight drums to process all these heavy crude oils and heavy oil fractions. I am I also want to to make a context about where this feed to the delayed cooking unit comes from. Here, I am presenting this very simple scheme of the atmospheric distillation tower and the vacuum distillation tower. When the crude that has been processed in the vacuum distillation tower is already fractionated here, the residue goes to the delayed cooking process. Here you can see where the fresh feed enters to the bottom of the fractionation tower that corresponds to the delayed cooking process. From the bottom, it goes to a fired heater. You can see here the fired heater. It is a furnace, and after the fired heater, this stream is sent here to the coke drums, where it is fed from the bottom of each coke drum, but it is not fed at the same time. It is not a simultaneous feeding. It is alternately feeding for each of these coke drums. Here in the coke drums, due to the heating here in the heater, uh, this this stream reaches very high temperatures, let's say like 480 or 500 degrees C. And the pressure here at the coke drums, the overhead pressures is about 15, it ranges from 15 to 35 psi gauge. Under these conditions, the cracking reactions proceed and then lighter fractions are produced. These fractions are in the form of vapors that are then sent to a fractionation tower where we can separate this fraction in gases, gasoline, and gas oil. So this is an upgrading process for heavy residues. you can see that it is attractive for these heavy residues because the heavy residues are not suitable to be processed in catalytic units. Here in this video, I want to see if I am able to wait to show this video. I don't know if I am okay. Well, in this video, let me see. Okay. In this video, you can see a very simple representation of the process. You will only see right now the furnace and one of the cooking drums. You will see that this is a semi-continuous process. A continuous flow of material goes through the tube furnace, and then materials are fed alternately into the drums. While one drum is being filled with coke, the other drum is being stripped with steam. It is also vented and cooled before opening this drum to the atmosphere. After the drum is opened, you can see that in this video. The opening of the drum is called usually the heading. Then you open the drum, you cut the coke with a water jet that can be observed in this video. That water jet has very high pressures. And then the coke is drained down to the coke pit. The vapors that are separated in this coking process in each drum, the vapors are sent to the fractionation tower as I showed you before. But this illustration is better to understand this process and why this is called a semi-batch process or semi-continuous process. The olefins and the products that you obtain in the fractionation column are more commercially valuable because they can be sent, they can be used in petrochemical industry, in gasoline blends and naphthas. And the coke can also be used in the aluminum industries, steel industries, and other chemical industries. One of the benefits of this process is the flexibility to handle heavy fractions. Okay, now I am going to this next slide where there is another representation of a scheme of how this cooking process works. You can see that there are tunnels that are formed in the solidified coke mass. So this steam can drag the vapors, the light vapors, to the fractionation column. This drum, you can say that it is in the cooking mode, while this other drum, it is in the cooking mode. It is in a, you can see that there is a, wait, that there, this water jet is represented here, and this water jet first perforates a hole along the mass of the coke that solidified in the drums. And then the jet is cutting the coke along all the walls that inside of the drum, and then the coke is directed to the coke pit where it is collected, where it is drained, the water is drained and it is recycled into this process. Okay, here it is a very common list of the operations that are involved in the coking process. Cooking process in the drums can run like a cycle for 16 hours. There are cycles that take longer, yeah, but this is a very typical way to list the different operations that are involved in the cooking operations. Now, the types of coke that you can obtain from this process are the shot coke that is not so desirable because it is too hard, it is difficult to handle, difficult to grind, it pops while it is burning in the kilns, so it reduces the thermal stability. this can be used as a fuel, but it is not so desirable in the process. But sponge coke, needle coke, they are higher quality cokes that can be used in manufacturing electrodes. Now, the central topic of this presentation, which is directed to the hazards in delayed cooking units, um, I well, I can mention here the chemical and the process hazards. About the chemical hazards, here I am showing a very simple table about the different substances that are present in this process. You can see that they can be irritant, they can affect the health of the personnel that operates the plant, they are toxic. So this is just to mention the chemical hazards in DCUs, and also here we are going with the process hazards in delayed cooking units. It is common that the most frequent hazards are related to fires, to explosions, and that is because of many streams in this process and deposits in this process contain flammable and combustible material. So personnel must take extreme precautions to reduce the likelihood of a fire. They, we also must consider the fire suppression systems and firefighting equipment that must be located throughout the unit to extinguish the fire. Here are some examples. Yeah? They are very common, like sprinklers, um, these fire monitors, also wildfire extinguisher, manual fire extinguishers, and so on. And also the safety systems to avoid these fires that are related to the installation of detection systems, relief valves, motor operated isolation valves, and interlocks. Other hazards that are present in delayed cooking units are the hot process lines and equipment, the discharges and escapes of toxic substances, also during sampling procedures and the steam vents, because any vent of vapor, including steam traps, exhaust lines, or relief valves to the atmosphere, they can cause injury to personnel. So the unit personnel must be aware of the specific hazards that are posed by vapor vents and their locations. Now, I want to mention some of the incidents, the accidents, fires, explosions that have taken place in delayed cooking units. This presentation that I am sharing today with you is a description, and it is like a reminding of these conditions that can cause critical critical scenarios that can develop in fires and explosions and fatalities. Here, this incident in Baton Rouge, in Louisiana, 1993, three persons were killed, three firefighters were affected, all the structure was destroyed, lots of money were lots of money in the damages were involved, and it was attributed to a faulty inspection. In this case, what was found is that one of the causes, of the main cause, was the failure of an elbow in the feed circuit. The feed circuit, you know, that is exposed to very high temperatures. The elbow was made of carbon steel and was installed in 1963. And the fire and explosion was in 1993. It was 30 years the refinery didn't know that this elbow with a mismatch metallurgy was placed in that critical part of the plant. The metallurgy required for this operation, for these conditions, was a 5% chrome steel alloy. So even though the refinery had enough inspection points, they mentioned the 51 inspection points, they were not aware of the presence of this faulty elbow. So the decisions that the company made was make a more robust fire water system with the pump that was specific for this coking plant. Other solutions were like to make easier egress for workers. If workers are located in the high levels for the cutting deck, the top head of the drums, it is difficult for them to egress to get away from the fires. So ideally, sprinkled stairwells should be available in this coker unit. Another solution was adding two gantries so the workers could egress very easily. Among the lessons learned, the high degree of inspection required to be confident about the materials, the specification, to be sure about the specification and identification of materials, and also to consider that there are portable materials identification systems, equipment that can be used in these cases. Another accident in Corpus Christi in 1995 that caused one fatality. What happened here is that the firefighter was sending hot material to the coke drums. But you see, for example, in this system, the drain line, that is different, is shared between the drums. It is only one drain line, and the operator opened unintentionally the feed while this drum was the coking, was draining hot coke. So what happened? Hot oil went down the drain. The description is here. It presented a flash fire, and the employee sustained fatal burns. The other employee didn't get affected by this accident. A very highlighted accident in delayed cooking units is this from Anna Cortez in Washington, 1998. In this accident, 6 workers were killed in a fire and explosion event in a delayed coker unit. Here in this representation, I am showing what happened once the refinery stopped all the operations due to a power outage. The power outage was caused by high winds. It was a storm. The storm caused a power outage. The refinery stopped everything. And then one of the drums in the delayed cooking unit stopped its function. And then the lines started clogging. They were clogged with the solidifying material. This material should be fluid, but once the plant went down, this started solidifying in the lines. And also some of the coke that was partially filling the drum started to solidify. Here it says when a normal cycle is interrupted like this, the procedure is to remove the coke. But in this case, since the lines were clogged, it was difficult to make this removal. The employees made several attempts to unclog the lines, to try to break this coke, but it was not possible. So they decided to open the top head of the drum. They also based these decisions because they had these temperature sensors located at the top, at the skin, and at the bottom. And they considered that the temperature of the content of the drum the temperature had a safe level, that it was not dangerous to handle this coke out of this drum. But they didn't know, they didn't verify the real temperature of these contents. They they didn't know that the only part of the coke that had cooled a little was only the coke that was in contact with the internal wall of the drum. So they decided, as I told you, they decided to open the top head, to open the bottom head, because that is the procedure. And once they started opening the bottom head, an avalanche of hot coke that was not solidified affected and killed 6 workers that were supervising these operations. Yeah? The coke started a fire. The workers got burned in this accident. So here, the analysis that went after this incident, this catastrophe, the suggestions are like lessons learned from this incident. Some attempt to measure the temperature of the material in the drum could perhaps have been made. They could have lowered a temperature device from the top of the vessel, but this would need specialist contractors. Also, technical support would take time. In these conditions, the drums and the delayed cooking units would could only be used at half capacity. But what they decided was not safe. They were not aware about the temperature that the contents of the drum had in that time, even though that they left like 1 day for these contents to cool down. So the faulty factors that characterize this accident are the permit systems. The permit systems was flawed. It was falsely determined that drum parameters were safe for unheading. The procedural development was faulty. The operator training, it showed that operators did not know the true hazards of these processes. And the management of changes, since this cooking unit was in abnormal conditions, the change management process should have been operated at that time. Well, after this accident, where 6 workers were killed, again, in the same refinery, in the same delayed cooking unit, one person was injured the next year in 1999. Based on these accidents that are repeated and the causes that are repeated, OSHA and EPA issued this bulletin, this safety bulletin, the chemical safety alert, where they mention all the hazards that are involved in cooking processes and suggestions for mitigation of these hazards. But even though after this bulletin was issued, the accidents kept happening. You can see here in 2004, one fatality, and this was because the employee was using this high pressure water to drill the hole in the solid coke. But the drill hit a hot spot in the coke chamber, and the water became steam, and it burned the employee, who later died at the hospital. Also in 2005, in 2009, we can see that there have been a sequence of accidents. Maybe they are different, but some of them share the same causes. here in Port Arthur, Texas in 2015. And here there are also another accidents that I found randomly searching on the internet. So, considering these repeated accidents, the lessons learned, and the risk controls that have failed, it is necessary to establish some prevention measures. Here I found some very interesting presentations in conferences about chemical engineering and about process safety. Here, this one addresses some of the accidents that I mentioned previously. A multiple fatality accident during drum and heading, a major fire due to interlocks bypassing, a fire due to unintended discharge of hot hydrocarbon to drain. And also this presentation, I have here like a sample of one of the screens that the slides that they presented. They highlight the importance of installing automatic devices, the emergency block valves that are helpful to avoid the workers to be close to these critical areas where they can be affected by hot temperatures, by high temperatures, hot avalanches, or anything. Well, one of the factors that characterizes this delayed cockers unit is the manpower intensity due to there are more than 20 operations involved in this process where people have to be exposed to these toxic vapor, toxic substances, high temperatures. Each unit has like 4 or 6 drums, as I showed you earlier in pictures. So these tasks are also performed at several levels of the coking structure, which is really high. You can see that some points are like 40 meters from the ground. So these high height tasks are really dangerous. Okay. Also, during these operations of coke drum switching, when you are changing the feed from one drum to the other drum, and then you need to close valves, and then you need to be sure which valves you are going to open or to close. This can this can be, well, confusing in some cases, but the mitigation, the suggestions to avoid this hazard is to install automatic valves for the heading and also for blocking some streams. Some some facts that can happen here during coke drum switching or during coke drum head removal are the eruption of geysers, because hot steam just goes up and can heat and can burn the workers. Also, hot tar ball ejections from the drain line and rainwater release and shot coke avalanche. Also, during platform removal, the falling hazard exists for the workers. Now, during these are other hazards that are present during coke cutting operations. For example, this cutting tool, if this is raised and the water jet is still working, is still streaming, it could dismember an operator. So it is important to isolate this tool while this tool is going up. Yeah. And there are also other emergency and general operational hazards during coke transfer, processing, and storage, the emergency evacuation, as I mentioned in the accidents that happened in these plants. Okay, so here are some suggestions for mitigation of these hazards: to operate remotely the systems that open, that close these drums on their top and or the bottom, to use color coding of valves to avoid the faulty operation, so the employees should always be in company. They should be in pairs in case that an emergency arises, and also some suggestions for mitigation of hazards during coke drum head removal and coke cutting. Also, it is important that during these operations of opening the drums, you have to establish restricted areas. Try to avoid that the workers get close to these areas where the coke drum is opened. In conclusion, what will help reduce the frequency and the severity of these incidents is keeping evaluating these hazardous conditions. You can use HACCP to identify these hazards, modifying operations to control hazards, modifications for the process to install automatic valves to operate them remotely, also actively maintaining an effective emergency response program and training workers about the risks and emergency procedures. Here are some of the references that I consulted. And to end this presentation, I want to thank Professor Savio, Maria Fernanda, for this kind invitation. I also want to thank the Universidad de San Buenaventura, Cartagena, for promoting this relationship with the refinery operations and the people who work there. I want also to thank my former students that today are engineers, and some of them are working at the refinery, Nicolás Navarro, Ronald Rios, Andrés Imitola, y Luis Miguel Peña. To all of them, thank you very much. To you who are attending this presentation, thank you for your attention. Thank you for your patience. I want to know if you have any questions to address at this point. Thank you.
Thank you, Juliana, for delivering such interesting and comprehensive presentation. It was really interesting. There are indeed a few questions here. Let me just organize them here so I can ask them too. So the very first one is, I know that you are very, let's say, involved with the undergrad and with the graduation students, preparing them to the market and so forth. And the accidents, some of the accidents that you have shared with us today, they present problems with materials, some of them, and other with the maintenance itself, right? Mm-hmm. So when the undergrad student is taking modules like material science and stuff like that, at first they tend to think, oh, this is not important. I don't really care about it. And sometimes they don't take that very seriously. But then when you look examples like this, and you can see that the very basic knowledge of materials or procedures can make a huge difference. So with that being said, how do you try to motivate your students and call their attention for the importance of every single subject that they take on the course, on the premise that at the end of the day, when they graduate, you don't really know what will be his job, and it might well be that he will need that knowledge. So how do you, based on your experience, you try to motivate them to, let's say, be more engaged on these subjects which are not necessarily in the core of chemical engineering?
Okay, thank you, Professor Savio, for this interesting question. For the students, they have seen that the universities are always engaged in promoting the learning about process safety and including some topics of process safety in each course. I have read several documents that say that, well, it is kind of difficult to start a specific course about, or several specific courses about process safety due to the intensity of the studies plan of all the curriculum in chemical engineering programs. Uh, but in our case, I remember by the experience that we have had with you when you have shared your conferences here about process safety, and with also the experience with other universities that have centers also for research in process safety, we identified some topics that can be included in each of the courses that are related with process safety. So once we start developing the syllabus of each course, we highlight the importance to include process safety. Also, you have seen that in our graduate programs, we include also modules that are in this topic, which is very interesting. Uh, the students say that when their professional life, when they are in the industrial companies, industrial processes, they remember how we were making the efforts for them to be in touch with these areas of process safety in every course. Thank you.
Uh, Thank you very much for addressing this. There are more questions here from the internet. So the very first goes like this. How do the operational challenges and potential hazards of delayed cookery units compare to those of other process within the petrochemical industry? And what are some key strategies to effectively mitigate these risks?
Okay, thank you very much for that question. I consider that question was kind of covered during the presentation. I showed the crucial scenarios that can develop in fires and explosions and injuries to workers. Uh, in the case of delayed cooking units, by from my experience from consulting with the people in this collaborative research works here at the university, the people who work at the refineries and come here to study, and they share their experiences. They say, well, the delayed cooking unit is really challenging when you compare it with other units at the refinery, because the conditions are severe, high temperatures, especially this is due to the high temperatures and also the height of the structure. You see? Um, well, some of these points were addressed at the presentation, so I can share it with you, or I can comment on them furtherly in more detail, because this bulletin that I mentioned, it says about this mitigation, something very simple. Keep your workplace in order, clean. You can see in several presentations from people who work at the delayed cooking unit, they say when you try to egress and you try to get away from an incident, then you see that the path is like blocked. There are obstacles because there are tools here and there are hoses here. And it is important to keep the paths cleared so you can egress easily from an incident. Also, the metallurgy. I have heard a lot from the people who manage these plants. They say the metallurgy is crucial. You have to make a very intensive inspection of every part in this plant. It can fail, the materials can fail at these conditions, these high temperatures. So you have to be sure that the metals, that the alloys are adequately installed in every part of the plant.
Yeah, yeah, absolutely. There's
Thank
one
you.
more question here. It comes also from the internet. So, what emerging technologies or approaches are being explored in the petrochemical industry to address the hazards and challenges associated with delayed cochlear units?
Thank you very much. Well, we know that HACCP has been traditionally applied to identify these hazards, but there are other techniques and methodologies like the graph system, and also the HACCP can be complemented with SEAL and LOPA techniques to identify and to quantify about the risks involved in this process.
I see. Yeah, absolutely. Let me see here. I'm just taking my mobile here to see whether we have more
Thank you.
questions. Just one sec. Let me check here on the internet as well. Yeah. Well, there's one more question here, and I think that probably you have addressed it as well. But I mean, I will pass that to you. Someone is asking: is there any international standard applied to hazard concept for biological process, for example? So essentially, the gentleman is asking if there's any international standard for the definition of hazard, the concept of hazard, and he's also interested in biological processes.
In biological processes, well, these biological processes, well, I consider that uh, there were some mitigation suggestions in the presentation about the personal protective equipment. Maybe I didn't mention them. I just went really quickly over the slides, but it is important and it is highlighted in those slides that the people must keep their personal protective devices and all the equipment to be protected from these biological hazards in cooking unit as in any industrial plant. Thank you very much.
Yeah, absolutely. I think that one thing that it's fair to mention is that protective equipment they play a major role in terms. It depends if you work on biological process, right? For example, the development of immunizations and stuff like that. Obviously, the research can get contaminated, and
Mhm.
one of the ways that he can mitigate it or try to avoid it is by the proper use of protective equipment, right? More recently, we've been through a serious pandemic issue, and the simple utilization of face masks, they helped a lot in, I mean, avoid the contamination by the COVID-19. So this is one of those examples. Uh,
And it is sorry, it is important that the person mentioned the biological hazards because this plant, as I mentioned, it is very manpower intensive, right?
yeah, absolutely.
You need the workers there.
Yeah. Okay, so I think that we are running towards the end of the seminar. I would like again, Juliana, to thank you very much and to thank you the Cartagena University for share you with us.
Thank
It's
you.
been wonderful, yeah. And once again, I would like to thank you very much and thank all the viewers in our YouTube channel. I would like to mention for those that are watching us that this video is going to be available. So if you want to watch it again, or if some of your peers missed it, they will have a chance to catch up later in the future. And if you have any particular question or any particular issue that you'd like to send to Juliana, we have her contact, as I mentioned at the beginning of the seminar. The university where she works has a memorandum of agreement with the University of Campinas. We work together, so it's very easy to get in touch with her. And
Yes.
I'm pretty sure that would be a pleasure to her to address any question that you guys might have. Uh, Thank you very much, Juliana, once more, and I hope to see you soon.
Thank you. Thank you very much, Professor Savio. Thank you very much, Dr. Maria Fernanda, for organizing this enriching space. This is very important for the university and all of our processes where we are collaborating, cooperating between institutions to promote these important topics for chemical engineering. So see you soon again. We hope to see you soon again in our International Congress of Engineering in November. Thank you very much, Professor Savio.